B.M. Ross and Associates has been retained to provide engineering and planning assistance to the township with regards to upgrades of the existing Shakespeare drinking water system. The upgrades are really related to providing improved treatment to address arsenic concentrations and iron concentrations. The goal of this presentation is to provide sufficient information to the people of Shakespeare so that they understand what was considered and what was determined through the study that we have done. The idea is that with enough information, then the community can provide feedback to council so that council can make a decision, an informed decision as to what should be built in terms of upgrades to the existing system. The presentation has a number of parts to it. We will review some historical background. We'll talk about how we came to be doing this particular study and what was done in advance of this. We'll talk about the investigations that we undertook to examine alternatives and come to an idea of what might be best. We'll talk about public and agency input that we received during the course of the study, and we'll talk about the conclusions or the findings of the study itself. The idea again here is to present details so that people understand the possible solutions and they can provide input to council. This presentation takes about between 50 and 55 minutes to work its way through. There's a fair bit of information provided. Before we get into the details of the presentation, there's a few things that we would like to make clear right up front. This is a project to really improve the treatment in the Shakespeare drinking water system. There are no plans to expand the water distribution system. There are mandatory connection to the system is not being considered or proposed. The primary purpose of the environmental assessment, which is really the type of study that we are doing, is to find the best solution for solving the arsenic problem. Something that we have established is that treating for arsenic also addresses other water quality concerns, specifically iron, which we know is a problem with the existing supply. And we know that adding a reservoir as part of the treatment system improves fire protection for the whole community. And if we do add storage, it does not mean that we have to expand the distribution system. That is not being considered. We're going to start with some historical background regarding this project so that everyone is aware how we got to this point and are doing this current study. In 2018, the province changed the standard for how much arsenic could be in a municipal water supply from 0.025 milligrams per liter to 0.10 milligrams per liter. These values are often expressed as micrograms, which would mean 25 down to 10 micrograms per liter. A milligram per liter is equivalent to a part per million. So really we're talking a goal here of 0.01 parts per million. Originally, the township was given until December 31st, 2021, to lower the arsenic concentrations. An extension has since been granted until September 30, 23, that's September of next year, to put in place the arsenic treatment and lower the concentrations in the system. The Originally, a Class EA to establish the best way to reduce arsenic was initiated in March of 2020 and completed in April 2021. So that is not the current study, that is a prior study, and we'll talk about what we did and what we concluded in that study. The 2020 environmental assessment study was what we call a high-level review of options. We examined 4 alternatives at that time. The first alternative was to drill a new well at another location. The goal would be to find a location that might have lower arsenic concentrations, so we wouldn't need to treat it. The second alternative involved modifying the existing treatment system, which would really be adding treatment to deal with the arsenic. The third alternative we looked at was modifying the existing wells. And we have learned from other locations that it's sometimes possible to isolate zones in the bedrock, that the zones in the rock that are actually contributing the arsenic. Arsenic does not necessarily come into the well uniformly and add layers in the bedrock, and sometimes it's possible to isolate a particular zone. And the fourth alternative was something that we always consider in an environmental assessment process, and that is to do nothing. And in the case of this particular project, and it's often the case in projects, is that doing nothing is not an option. We are required to lower the arsenic concentrations, and you're not going to do that by doing nothing. So something must happen. Through the course of the study and our examination, we concluded that modifying the existing treatment system, which is essentially providing additional treatment for the arsenic, was the preferred alternative. It was really the only feasible alternative in this case. As part of every environmental assessment, we have a consultation program. It's a big part of what is done. An initial notice was in 2020 published in the local papers. Letters were sent to review agencies, and an example would be the Conservation Authority and the Public Health Unit would be another example. The Ministry of the Environment at the time would be an example, and also to Indigenous communities who get the opportunity to provide input and comment on projects. A copy of the notice was mailed to the customers of the Shakespeare water system, and updates were sent to the water customers twice after the initial notice, once in October and again in February of 2021. By February 2021, we knew what we wanted to do going forward. As a result of that consultation, we received 4 responses from the community. 3 of them were customers, and 1 was from the community and an individual or property owner that was not a customer. The comments related and questions as well related to water quality for example, was arsenic a concern for them? When was this project going to proceed, and what might it cost? So we received those comments, we responded to those comments, and we, in April of 2021, published a final notice, finished uh, our draft report, we called it, and published a notice in the local papers, sent it to all the customers of the system, and uh, uh, invited feedback again. There was, as a result of that final notice, there was very little comment received. We went on to publish our report and again put it on the municipal website for a 30-day review period. The focus in terms of public consultation and invitation was really on the existing customers, because it was believed at the time that this was really about upgrading the system for the existing customers. Now, once we had concluded through the EA process that the best solution was to add additional treatment for arsenic, we then proceeded to find out what exactly would be the type of treatment that we would add. In the original EA, we did some preliminary work to confirm that we could in fact treat for arsenic, but there's a number of different ways it could be done. And it was after the EA process, through May to July of 2021, that we really began to look at different technologies in detail. One of the things we did was retain the Walkerton Clean Water Agency, Walkerton Clean Water Center, to help us do pilot testing of the different technologies. One of the technologies we looked at was something called cartridge filtration. In treating for arsenic, the most common treatment approach is to just simply filter it out. And one of the technologies available for filtering is cartridge technology. So a lot of small residential swimming pools use this kind of technology as well. But we concluded that although cartridge technology would be quite a bit less expensive to install, it would be very expensive to operate, because the iron in the water would tend to plug the cartridges very quickly. So we'd be replacing cartridges several times a week. So in the end, we rejected that technology and went to a more conventional filtration technology that would involve having mechanical filters and systems to backwash those filters periodically. We then went on to request quotations, and we received proposals from 4 different companies with really 3 different technologies to remove the arsenic, all using filtration and backwash systems. By the late fall of 2021, it was apparent that constructing a filter system with backwash capability on the existing site was going to be very difficult and very expensive. And I'll explain why it will be difficult and expensive a little later on in the presentation, but that was the conclusion. So in October 2021, just a little over a year ago, we made a presentation to council and recommended that we proceed with a second environmental assessment, to examine the feasibility of providing treatment at an alternative location. Not necessarily the existing site, but perhaps some other location in Shakespeare.
Following the presentation to Council in October of 2021, the new EA process was initiated in January of 2020. And the specific goal of this EA, which is the one that's currently underway, is to determine whether or not it is feasible and desirable to provide, in addition to treatment for arsenic, a reservoir storage system that will meet a number of additional goals. So one is to meet the short-term goal of improving water quality by providing storage for the backwashing of the filters that Steve explained earlier is part of the preferred treatment method. The other is to create the opportunity to improve fire protection in Shakespeare, which would be a byproduct of having some additional storage. And the third goal would be to ensure that money spent on improvements now also considers the long-term interests of the entire community. When municipalities undertake Class EAs, the level of examination that's undertaken depends on the complexity of the EA. In this case, the Class EA process is triggered by the potential upgrades to the water system, and it's what we call a Schedule B Class EA, which means we have to complete the first 2 phases of a Class EA. We are currently in phase 2 of that process, so we're nearing the conclusion. In a more complex EA, you might complete all 5 phases, and in the subsequent phases, you would look in more detail at the alternatives once you've selected a preferred alternative. In this case, we're at the stage right now of evaluating the alternatives that have been identified and selecting a preferred alternative moving forward. And that's the key point of this presentation, is to have the public provide input to allow council to select that preferred alternative. So in this current EA, we did a similar type of consultation to that was completed in the EA from 2020 and 2021. There are standard points of consultation that are a requirement with any EA. A notice has to be published in a local paper for 2 consecutive issues. And in this case, as with the previous, the notice was published in the Stratford Beacon Herald and Marketplace. Similar to the previous EA, notices were also sent to review agencies, project stakeholders, and to Indigenous communities. And because the outcome of this EA could potentially impact other residents other than the existing water users, a decision was made to contact everybody who lives in Shakespeare, all the property owners, to give them an opportunity to also comment on the process. As a result of those initial consultation efforts, we received approximately 32 submissions from residents, mostly by email. A lot of this consultation was occurring in the midst of the COVID epidemic, and so we were all working from home, and so a lot of the comments were via email or by phone. And then we noticed in some of the responses we were receiving from residents that there was some confusion over what the purpose of the EA was, and some assumptions as to what was going to happen. And a decision was made in April following that initial consultation phase that we should send an update letter to residents to clarify the purpose of the EA process. And so that occurred in April of 2022. And again, the letter was sent to all residents owning property in the community, everybody who was initially circulated as part of the EA. And that second period of comment extended to May of 2022. And as a result of that, we received an additional 15 comments from residents. Some were from the same people that commented initially, but we did receive some additional comments from people who had not submitted any comments initially. To summarize the feedback that we received from residents, we've put them into some general categories. So the first group were comments related to the municipal water system. Many people feel that the water quality currently in that system is not very good, And majority of the people who responded indicated they have absolutely no interest in joining the municipal system if they are currently on a private well. We also had a number of comments and questions related to the environmental assessment process. Many were concerned that the EA will result in private well owners being forced to connect to the municipal system. And that concern was around the fact that many had invested in upgrades in their private well system. Also, the previous comment about water quality and concerns about costs associated with being forced to connect to the municipal system. There's also a perception in the community that there are no concerns with water quality in those private well systems. And that there was also just a concern about unnecessary costs to residents.
In the 2021 environmental assessment, it was established that we couldn't modify the existing wells to reduce the arsenic concentrations, that would not be feasible. We also established that it didn't make sense from an economic standpoint to look for water elsewhere. And there was a high likelihood that if we drilled wells at other locations, we would still continue to have the arsenic problem. Subsequently, we started a preliminary selection of equipment, and it became apparent, mostly because of site constraints, it was going to be challenging and expensive to treat for arsenic at the existing site. When I talk about site constraints, I'm really talking about principally about the width of the site. It's very narrow. We then initiated the second study, which is the current study, which would examine if it makes better long-term sense and really better use of available dollars to treat for arsenic elsewhere in the community. The idea being that a larger site allows us to have a reservoir incorporated into the works rather than trying to store water for backwash in a tank within the building. The next few slides, including the current slide, deal with really the technical aspects of the current study. The existing wells currently, the drinking water system, and there's 2 wells, currently serve 160 properties. And at existing usage rates, we believe they could serve approximately 248. There are approximately 400 properties, developed properties in Shakespeare. We established that we know that treatment for both arsenic and iron is required, although we also have established through pilot testing and so on that the same device that would remove arsenic will also reduce iron. We know that that additional pressure tanks and other modifications are required to modify pump cycling. The present system, when it operates, the pumps start and stop quite frequently because there are really insufficient pressure tanks within the pump house building, and there's no room to add more. So that would be another thing that we would address at the same time. We also know that the existing system does not support fire protection in any way. The capacities of the wells really do not provide a fire flow that would be useful to the fire department. So some of the issues, and I talked about them very briefly, is that the site is very constrained. It's less than 6 meters wide. It's not much wider than the actual pump house that's on there now. We know from our efforts to select equipment to get an understanding of what equipment might be installed for arsenic removal is that we would need a building about twice as big as the current building. We know that if we are to store water in the building for backwash purposes, and it has to be, we need to backwash with treated water. And to fit the amount of storage that we need, which is somewhere in the order of 1,500 gallons or so, it means that we would need an inside building height in the order of about 7 meters, over 20 feet. The reason it would have to be so tall is that the narrow site does not allow us to really have an excavation and have a lower level for this storage tank to sit on. It needs to sit on at more or less the present grade level. We know that to access the expanded part of the building, the addition, requires extensive renovations to the existing electrical system. The electrical facilities, the motor starters, controls, the power supply, and so on, is switches and all that type of electrical gear are on the back wall of the building and will be in the way of trying to extend the building. So they would need to be removed, replaced, or modified in some way. So that would be an effort. We also know that the electrical service size, and more particularly the phase of the service, is something that we would want to address. This facilities will work much better with what is called three-phase power than they would with the current single-phase power. We know that we can bring three-phase power from County Road 107, so it's available, but it really would have to be brought to the site, and so that's an issue that is solvable, but would need to be done. What we're looking at now is a picture of the existing site from the rear of the property. Immediately in front and to the right there is well number 2, and this photograph was taken shortly after the installation and connection of well number 2. And it shows that the property is very narrow. We're very within a meter of the property to the east, and within a meter or less of the property to the west, and there's a garage there as well. So it's the very narrow site that provides a constraint for us. In every EA process, we examine alternatives. And in the first EA, I talked about them being high-level alternatives, and which included even looking at the possibility of finding another source of water. In this case, the alternatives are more detailed. We have two alternatives, and one is to provide treatment for arsenic and iron at the existing well site, providing we can find a solution to the fact that it is so narrow. And the second alternative is to provide treatment at an alternative site somewhere in the community that hopefully would maximize future opportunities. And again, in an EA process, we look at the do-nothing alternative, but again, the do-nothing alternative is not feasible here because the province requires that we reduce arsenic. So treatment at the existing site. So what it would involve is the addition of filtration equipment to remove the arsenic and iron. Uh, Associated with that treatment equipment would be a storage tank that would be made out of plastic or fiberglass, be several meters tall, and it would hold treated water for backwashing the filters periodically. The foundation of the tank or the bottom of the tank would be at more or less the same floor level as the existing pump house. The filters and storage tank would be both be located in an addition that would be on the north side of the existing pump house. So what we have here is a what's called a plan and section of what the pump house building might look like with the required addition on it. And at the front we have the existing pump house, and at the rear of the pump house, the existing pump house, we would have the addition. And it shows the filters along one wall, really, which they're circular in their in shape, and at the back would be the backwash storage tank that treats holds treated water for backwashing the filters. When a backwashing is occurring, the discharge would go out to the sanitary sewer in the front. And it's a tall tank that is really requiring us to have a very tall building addition. We can't excavate significantly, just enough for foundation walls, because an excavation, after we completed the side slopes and had access for materials and so on, would extend well into the adjacent property. So we're going to have an addition here that is very tall if it proceeds at this location. And we, on this picture here, we are showing what that building addition might look like. So this is really our drawing in 3 dimensions superimposed over a photograph of the existing area. And you get a sense of what it would look like, the height of it, and so on, and where it would fit on the property. So the conclusions with regards to providing treatment at the existing site are that it cannot be done without the full agreement of the 3 adjacent properties, east, west, and north. The reason is there is insufficient width for a safe and legal excavation. So we can't dig down, we've got to build up. And even if we can do that, even if we could, we would need access for equipment and materials, which are generally going to have to come mostly from the north side. But we would need really the agreement of all 3 of the adjacent owners. The township has reached out to all 3 owners, but so far does not have their consent to proceed with encroachment on their properties. One of the things that we know from the existing site is that 248 customers could eventually be served from the existing well supply. We're not really increasing the capacity of the wells or their ability to service beyond what they can do today. So even today they service 160, but could service up to 248 at existing usage rates. The probable cost, we believe, to do what we would need to do at the existing site is just a little over $1.9 million. So, treatment at a different location is the second alternative. Given the challenges that we knew we would have at the existing site, we felt it might be feasible to provide at reasonable expense treatment at an alternative location. And if we did that, we might be able to include a reservoir at that same location that would have a number of benefits. One of the difficulties of treating water at a different location is that we would have to pump the raw water, the untreated water, to that location from the existing wells. And then once we treated it, connect it back to the distribution system. We don't have to go take the treated water back to the existing well site, but we have to connect at the closest convenient location. So in going to a different site, we would add the costs of what we call the raw water pipeline or water main. So we looked at municipally owned properties as well as a site immediately north of the existing site on the adjacent property that's not municipally owned, but we had some indication it might be available. So we looked at, we determined what could be constructed, and there are a number of options, and who would benefit and what will it cost. So this is a map or plan of the existing, of the community and the existing water system. So we looked at 4 alternative locations in addition to previously looking at the existing location. So location 1 was immediately adjacent but north of the existing wells. So it's in this area here. Location 2 is between Stevenson Street and the highway. It's a vacant property owned by the township. And right now, what's on that property is a sidewalk that connects Stevenson Street to the sidewalk at the highway. The third location we looked at was on the property, at the property on the corner of Road 107 and the highway. And that's, right now there's a commercial development there. There's quite a large parking area, and part of that is owned by the township. And then the last location, we call number 4, was somewhere adjacent to the existing community center property. There's quite a bit of area available to us there. So those are the 4 locations we looked at. So out of those 4, we picked one that we felt was the best. And we established that Site 1, which is the one immediately to the north, did really not give us any opportunities that don't exist with trying to treat the water at the existing site. We would have to purchase the site. It's not municipally owned. And when it comes right down to it, in the end, it's only marginally better than the existing site. It is also, although potentially slightly wider, it is still constrained. Sites 3 and 4, which were, the 3 was at the main intersection, 4 was the community center, really offered no advantages over Site 2. And they would actually be more expensive to develop because we would have to take water further than we would at Site 2. raw water from the pump house to the treatment site would be a longer pipeline than at site 2. And in addition, we would have to cross the highway, which has its own complications and expenses. So given that site 1 is still quite small and offers no advantages, sites 3 and 4 are more expensive to develop. Site 2 is the preferred location. And we know site 2 is adequate in size, it's reasonably close to the existing wells, and it's accessible to the wells and the distribution system.
What we have here is a photograph of Site 2. The photograph was taken from the south side of Highway 7 and 8, looking north towards Stevenson Street. So what we have here is what is essentially a vacant lot owned by the township. On the right-hand side of the photograph, east side of the lot, is a sidewalk that extends from the sidewalk on the highway through to Stevenson Street, and that the site is large enough for a reservoir and a treatment building, and we can maintain that sidewalk.
So we next looked at what could we build at site 2. Well, we could and we refer to these alternatives as 2A, 2B, 2C, and 2D. 2A is really just adding treatment for arsenic, adding filters in a building at that location, and those filters would treat for arsenic and iron, but we would still have tank storage similar to the existing site, but in this case, we could have a 2-level building. We could have an excavation such that we could set the tank on a lower level and have a common roof line. So it would be a better looking facility. In alternative 2B, we could, in addition to the treatment facilities in a building, which would be at ground level or grade, we could construct a reservoir with reinforced concrete walls in really what would be the basement of the treatment building. So if we have a reservoir that is in the order of 3 or 3.5 meters or 4 meters deep, which would be pretty typical for a concrete reservoir, we would achieve about 345 cubic meters of storage. And that would be in lieu of having a plastic or fiberglass tank in the structure. One of the advantages of having a reservoir storage is that the capacity of the entire system is really effectively increased. In 2B, we are not introducing the opportunity for fire protection. That comes in 2C. In 2C, we could add within the treatment building fire pumps, larger pumps that would provide enough water to make hydrants useful for fire protection purposes. So we're in 2C, we have the same reservoir size, which is effectively the basement of the treatment building, but we've added fire pumps, and therefore we've really improved fire protection within the community to some extent. And then in 2D, we looked at constructing the possibility of constructing an even larger reservoir. The province publishes design guidelines and recommendations for how much water should be stored in a community, typically based on population and so on. And for a community the size of Shakespeare, they would recommend a little over 700 cubic meters of storage, and that would require the reservoir to extend out beyond the limits of the treatment building. And I'll show a drawing as showing what that might look like in a minute here. So this table summarizes a number of things that we have concluded through our investigation. So option one which is to provide treatment at the existing site, is the least cost alternative. It would allow the system to serve up to 248 customers, and it would cost just a little over $1.9 million. So that's information that we established for the existing site. And that's all conditional on the 3 adjacent property owners giving us permission to encroach on their properties. For 2A, we are providing really the same facilities as we would at the existing site, doing it in a different shaped 2-level building. We would be able to serve 248 properties because we haven't provided a reservoir yet, and it will cost only about 3% more. So even though we would have to have a raw water pipeline that extends from the existing well site to site 2 and have a different type of building, it can be done at really more or less the same cost. In 2B, we are, instead of having tank storage, having reservoir storage. That reservoir storage increases just by its being present, it increases the capacity of the system so that it could then serve 436. It's not a goal of the project to increase the capacity, but it's an opportunity that could be done. Now, to build a reservoir adds costs, so the costs get closer to $2.4 million. But we can serve almost 200 more properties eventually if we wish. If we add fire pumps, that increases the costs again from 2.4 to just a little over 2.6 million. And if we have a reservoir sized consistent with the ministry's or the province's design guidelines, the cost would increase to about $2.85 million. So alternatives 2A to 2B, really it's a case of the more you get, the more you pay, the more you will get, the more benefit you get in 2 ways. You can eventually serve more customers with the same wells, and at some point here you will get the benefit of fire protection. So this drawing shows it's what we call a plan view looking at from the top, and a section view looking from the side of what option or alternative, I think we call them options at this stage, option 2D would look like. So we have the reservoir, which is underneath the treatment building, and it extends out beyond the limits of the building. So this is the largest facility that we have contemplated construction. So we have the treatment equipment here, we have the fire pumps here, service pumps here that pump treated water into the distribution system, and a reservoir underneath the entire building with a little over 700 cubic meters of storage. Now, 700 cubic meters is 150,000 gallons, approximately. So we have, in terms of how that looks on the property, this drawing on the right, or sketch on the right, shows the limits of the property. It shows where the building would be and the reservoir that could be built at the back. Now, one of the options that we've thought about after we drew this drawing, prepared this drawing, was it might make more sense for access to actually put the building at the back of the property and have access from Stevenson Street. But in the end, it would look the same. It would just be backwards from the current drawing. And this is an image, again, our drawing superimposed on a photograph showing what it might look like if it were there. And in this case, again, it's at the south side of the property fronting on Highway 8. We could do the same thing in reverse, have it front on Stevenson Street. But it shows that we can fit it in and retain the existing sidewalk and so on, and it would sit there. The front of the building in this view is really essentially at the front, same setback from the road as the house on the west side. And this is another sort of view of the same drawing. The reservoir would be mostly below grade. It might extend up slightly. It would be covered in grass and so on. So there would still be kind of a park-like effect there, and access would still be maintained. So before we move on to next steps, I just want to briefly summarize. So we looked at, when you count the existing site, we really looked at 5 possible locations where we might provide a treatment facility. So the existing site and 4 others. The existing site is very small. To actually have a building expansion to provide treatment facilities would require the agreement of the 3 adjacent neighbors to allow us to encroach on the site. And even with that agreement, it would be quite expensive. We would be incurring expense that is really related to just making it fit on the site. Of the 4 other sites, other than the existing site, we concluded that Site 2, between Stevenson Street and the highway, is the preferred location because it's only marginally more expensive than the existing site, just 3%. And it's big enough, it would allow us to do what we need to do. And if it is chosen, we could provide a reservoir and potentially fire pumps that really benefit the entire community by enhancing the existing level of fire protection. So that's what, through the EA process, that's what we looked at, and that's where what we have concluded. So next steps.
So at the beginning of this presentation, we indicated that the purpose of this of the presentation itself is to provide information to residents, giving them the background information they need to provide input to council, so that they can make a decision on this EA and we can move forward with the environmental assessment process. So the next step is to collect that input from residents following the open house and provide that input to council. At the open house, there are going to be comment sheets provided to everybody who attends, where we're going to ask for specific input on the different alternatives that are being considered. And that information will be tabulated after the meeting and provided to council. And then shortly after, the open house council will have an opportunity to review that information and choose a preferred alternative, a location, and the type of facility that they would prefer be selected. At the same time, then we would put together an update letter that would be sent out to agencies, First Nations communities, and to residents, advising them of what alternative council has selected as a preliminary preferred, and so that we can gain additional input from residents after they identify what council has selected. We would then work on finalizing the draft environmental assessment screening report, which documents the process. We would then collect input from those groups as a result of the update letter that was sent out. And following a review period, we'd prepare a summary of that input and present that to council so that they can confirm selection of the preferred alternative. And once that selection is confirmed, we would finalize the report and publish a notice of study completion, which would be posted again for a 30-day mandatory review period. As well, the report would be posted on the municipal website so that everybody has an opportunity to review those final steps in the Class CA process. And so that's the conclusion of our presentation. If anybody has any questions about the presentation prior to the public open house, which is scheduled for December 13th, you can contact BM Ross and Associates. You can email Kelly Vader at kvader@bmross.net, or you can call our office with questions at 519-524-2641. Thank you.